Welcome everyone, this is Mark from Osmio Water. So the purpose of this presentation is to explain the differences between various hydrogen and mixed hydrogen-oxygen breathing machines. Now it's specifically about breathing machines and not about hydrogen water anything, because there is a limited dosage one can get from taking a hydrogen type product in a water form. Whether you're using any type of product, there's only so much water you can drink, and your dosage is therefore your volume of water you drink plus also the amount of hydrogen in it. So when you're breathing, actually you are getting a much higher dosage of hydrogen or mixed hydrogen oxygen. So this is a presentation for people looking to understand the spectrum of different technologies and machines out there that produce breathing facility. So let's talk about that. So next thing, they all use electrolysis. So we just need to fundamentally establish that there is a reaction going on with anode and cathode, and there's an electron flow, and we are basically breaking the electrical bond between hydrogen and oxygen. With electrons. We're smashing the weak electrical bond between hydrogen and oxygen by smashing it with electrons. And so you get this oxidation and reduction separation, basically. So all the machines out there fundamentally use electrolysis, so just to establish that. So a fundamental difference between breathing machines comes down to when you first set up the machine, is whether you only add pure distilled 0 TDS, zero dissolved solid water into the machine, or whether you add an electrolyte, which is something which will conduct electricity in the solution when you first set up the machine. So there are two types of breathing machine broadly, ones where you do add an electrolyte and ones where you don't add an electrolyte. So an electrolyte, just to be clear, is the thing in the water. They're usually salts or polar covalent compounds. In our machine, the Osmio Infinity, it's a Brown's gas mixed hydrogen oxygen machine, which uses an electrolyte, which is sodium hydroxide. And we'll explain about why we're using that and not other machines which actually don't and use something called a proton exchange membrane. So it can be very difficult to know exactly what you're looking at when you see like a box that you attach a cannula to. So it's worth explaining that there are three basic categories of machine. You can find ones that will generate just H2 gas, and they use a PEM, proton exchange membrane. You have ones that will generate H2 and O2, actually separately using a PEM and recombining later on. And then you have another group, which is the one we're actually focusing on as a company with the Osmio Infinity, which is the Hydroxy, Brown's gas, HHO, oxyhydrogen, whatever you want to call it, one group. And we'll first go on to explain exactly how PEMs work. So basically, proton exchange membranes are using a polymer layer as a form of electrolyte to provide a conductivity between the anode and cathode plates. So our hydrogen bottle is exactly that. It's a sandwich between a cathode electrode, a proton exchange membrane, and an anode electrode, just like that. Now, over here on the right hand side, you've got an example of how that sort of format is constructed into a larger device, which is then put into a breathing machine. So there are differences in breathing machines that use PEM membranes. There are ones that will give you hydrogen gas, and there are ones that will give you a mixture of hydrogen and oxygen gas. So they're all making the oxygen gas as well, but they are maybe venting that out the room. Whereas there are machines that are giving you a separate, they're actually creating the reaction using the proton exchange membrane, making the hydrogen and oxygen separately, and then recombining them later on. So effectively, a proton exchange membrane is just a great big sandwich in the middle of the anode and cathode plates. But in a hydroxy Brown's gas machine, you've got a completely different situation going on, whereby you've got no membrane in the middle there. In fact, you've got the electrolyte in the pure water is providing the transfer of electrons between the anode and cathode. So down here is a zoomed in example here. So with a hydroxy HHO Brown's gas machine that doesn't use a PEM membrane, that would need you to mix electrolyte with the pure water, it works like this. It has nothing in the middle, no proton exchange membrane. So if you imagine this is a hydrogen-oxygen molecule, it's being split like that apart. But out of this split comes a reaction. Now, there's a whole heap of other gases which are created out of that reaction, which are not created in the PEM machine. So for example, it's monatomic hydrogen, diatomic hydrogen, H2O is water vapor, there's H3O2, which is hydrogel or easy gel. There's electrically expanded water, which is probably linked to the creation of the easy gel. And then you've got diatomic oxygen and monatomic oxygen here. So all of these are being created out of a reaction. Now this split that happens right here creates it's almost like a portal from a position like this that creates a flood of negative electrons that come out of that reaction. And that flood, this portal, is blocked by a proton exchange membrane. But the portal is opened by there being nothing in the middle. Now there's more investigation that needs to happen into this little bit right here, right there. What is actually happening there and how it's happening, because more than likely this whole cluster of negatively charged electrons that's coming out of here isn't there before the reaction occurs, and it's created out of the reaction from somewhere in there. So that's something else that needs to be looked into. But the point is that a whole different mixture of hydrogen and oxygen is created out of a Brown's gas type of machine. Now, a very, very important consideration when looking at any breathing machine is to do with its safety. Now, as much safety as can be built into a machine, this section is talking about the safety with regard to the concentration that you're actually breathing through a cannula, through the nostril. It's that concentration which is fundamentally important, because there's a safety element in that. So it's fundamental that that concentration does not exceed 4%, and the safe level to operate at is really 2%. So how do you actually calculate that? It's basically based on the total resting inhalation breath volume over its time, and the amount of hydrogen that's coming through the cannula at that time as well. So, and working out the percentage of that. So concentration is basically the volume of hydrogen coming through the cannula divided by the resting inhalation volume minus the amount coming through the cannula, if you take the total nostril. Now, I'm not going to go into detail about the surface area of the cannula and the nostril, because you could get into more detail about. Let's just do a rough calculation here. So let's do that. So an example with the Osmo Infinity operating on 40% duty cycle, the actual amount of H2 coming out of the cannula is 33%. The amount of H2 coming out of the cannula is 333 milliliters per minute, which is actually 5.55 milliliters per second. Okay, so now in an average person, adult, let's say, their resting inhalation breath volume could be around, say, 600 milliliters in 2 seconds. Obviously, that can vary, but you can easily measure that. So 600 milliliters in 2 seconds, let's say, which is about 300 milliliters per second. So to calculate the concentration there, you've got 5.55 milliliters of hydrogen per second divided by your 300 mils of resting inhalation breath per second minus that amount of hydrogen multiplied by 100. So in that case, it's 1.9%, which is smack bang where you want it. So Obviously, above that level, I mean, we're talking about hydrogen and oxygen, which are easily ignitable gases. Now, in the ignition, if there is a static spark which sets it off, or if someone lights a cigarette while breathing the cannula, there will be an explosion. And in the Osmia Infinity, that's designed to happen if someone actually did, in that situation, that actually happened, and it would explode where the concentration of hydrogen is greatest, which is that way where the bubbler is. And that's why the bubbler, the humidifier 2, as it's called, is a thin, very thin plastic bottle which is designed to shatter and explode and not cause any damage. So what is important is to calculate the amount of hydrogen coming through and not using a face mask or anything like that where the concentration can build up, because the lungs and the breath sort of passage is an environment where the concentration could build up. So it's just important to keep it at a safe level and to be actually grounded your electrical potential to the machine, to make sure that you're taking the right precautions to not generate static. So you would not be stroking your cat while you're breathing with a cannula, an explosive gas, because that spark can ignite the explosion that way to the machine. And you want it to be that way and not the other way, which is someone's lungs. And that's why I'm talking about calculating the concentration, because there are machines out there which claim to do up to 2 or 3 liters per minute of this gas, which people think is actually good, which we need to actually address the fact that there's a resting inhalation breath volume and there's a concentration of hydrogen, and that's how you calculate the concentration. So it's nothing to do with the safety of the machine, it's all to do with how people use the machine and use it in a safe environment. So when we actually do our machines, people are trained in this anyway. So when you get an Osmia Infinity, you actually will go through training, even so that you make sure that people who have a machine, if they give it to anyone else and use it on them, they know exactly what they're doing. They know there's a safety issue to do with how people use the machine. Okay? So just to recap some really important safety precautions, as you can see, you need to make sure that concentration is 2%. You also need to make sure that you touch the machine to equalize your potential energy to the machine, to make sure there's no static on you that can generate a spark, which can then go, which can even touch the tubing of the cannula, which can generate an explosion that to ignite. There we go. And also to be aware that someone else coming into the room can also be of a different potential energy. So if they touch the cannula, or even you, that could change the situation as well. So when you're using a machine, just be careful about obviously not stroking your cat, or using more staticky clothing like polyester or sort of nylon type clothing can generate more static. And actually then, you know, make sure that you're not in a staticky environment. Even excessive humidity can be an environment which is causing much more static to be around. So grounding is important, and while you're using the machine, and being aware that someone else can introduce a spark to the equation as well. So it's best that you keep animals and other people away while you actually use the inhalation machine yourself. Okay? A really major key consideration for any type of breathing machine, for hydrogen or mixed hydrogen, oxygen or Brown's gas, is ensuring the purity of the gas. So the gas is pure because the water that you're using in it has to be pure. So you need distillation, or with good carbon filtration for gases that are below water boiling point. You need, or ideally, RODI. As a way of actually applying pure water that, you know, if you need to maintain and make sure it's hygienic and free from bacteria, you need to clean it and regularly change your cannula and clean the tubings and make sure the machine is hygienic and well kept, and clean the bottles and change that water frequently. So as the water is humidifying or moisturizing the gas, as well as scrubbing out any microscopic impurities that are in there, which could be from the electrolyte or atomized metals and things like this. So it's really important that you are frequently changing the water and frequently ensuring that the water outside of the machine, in this case, is actually filtering the gas and ensuring its purity. So that needs attention when you're using a breathing machine, say on a daily basis, or even not, or even more so if you're using it less often, because you're leaving it with, there is H2O as water vapor in the gas, so you'll see that moisture potentially build up in the cannula as well. And you'll see hydrogel build up in the cannula eventually as well, and the tubing. So those tubings and cannula need frequent cleaning, like syringing through with sodium hypochlorite from the osmiosanza or similar things like that. So that's what you need to do to keep the machine clean. It's ultimately what's going to be going into your lungs. So if there's microbiology in the tubing, that's going to introduce that into your lungs, and we don't have that. We keep it really clean. It's good to use an osmiosanza, syringe sodium hypochlorite, or use Milton tablets, whatever's easier. And then you keep your machine clean. And cannulas are something you can replace. They're going up your nose. There's bacteria there, so obviously clean them after every time you use them, as well as change them often as well, because they're not expensive, but you shouldn't overuse them. Okay. So I want to get to the point about why we're focusing on Brown's gas, given that, you know, it sounds a lot easier just to put pure water into something without mixing an electrolyte, and then you've got the whole issue of using an electrolyte and scrubbing that out, and then you've got the issue of cleaning the machine and a bit more maintenance involved. So there is this. I mean, each machine out there does have pros and cons. So a PEM type of hydrogen machine is effectively easier to set up and get going. In fact, a downside of them is, and this has happened to a lot of early machines that came out, is they break. The PEM breaks. We get it with our hydrogen bottles a lot, which is like a miniaturized version of that. We have to fix them, but it's very difficult to fix the generator inside a breathing machine. So often that part, which is the most expensive part, has to be replaced, which doesn't happen with a Brown's gas machine. So Brown's gas machine is more simple and easier to service and keep going. So when you do buy a Brown's gas machine, Osmio Infinity from Osmio, we keep it going for as long as it needs, and they're always serviceable and repairable. But the point about why Brown's gas, given that it has its drawbacks, so why we're using an electrolyte-based solution, is to do with, number one, about the additional gases that are created. And now this is just a photo from Dr. Pablo Camperin, University of Almeria, who was sent our machine, the Osmio Infinity Brown's gas. But he also has the a Type 2 medically approved device in China, mixed hydrogen oxygen machine, and he was testing them side by side based on bubbling water and just checking the ORP. So let's see what he found. Okay, so this is using a oxidation reduction potential ORP meter, bubbling it through the same control water, so it will be the same 0 TDS, the same pH, whatever it is, and it's going to be bubbled through using two different machines. One is the Osmio Infinity, so that's the blue and the orange line, at different flow rates. So you've got the 40% setting, which was doing 533 milliliters per minute in total, and you've got the 100% setting, which was doing 833 milliliters per minute, and you've got the this is a Type 2 medical device that was actually giving mixed hydrogen oxygen at 3 liters per minute as the grey line. And what the experiment showed is that the over seconds here and the ORP going negative actually then reduced to a lower level and actually quicker than a machine that was doing much higher the flow rate. So we've got 533, 833 milliliters per minute, and then you've got 3000 milliliters per minute with this machine. So that's the reason why we're looking into Brown's gas, because now I'm not going to get into a discussion about ORP, because ORP is an indication of something therapeutic, but it's actually all about what is causing the ORP to be changing, and it's actually the presence of the H2 in the water, because the gas coming through is pure. You could argue that there are other things that can affect the ORP in water which are actually toxic, but in this case it's the hydrogen in the water and the electrically expanded water, mainly the electrically expanded water, that's actually enabled a machine at a fraction of the flow rate to reduce the ORP to a much lower level. So it's just an experiment. It doesn't prove electrically expanded water, and it doesn't prove anything other than the fact that on an ORP meter it reduced it further quicker. But when it comes to actually practical results, so if I can talk about cases that happened in clinical trials in China versus ones that we've had practical experience with, there is a difference there. So I wanted to highlight some of the clinical research that was done by Zhong Nanshang in China for the Type 2 approved machine in China, which has been used in 7 major Chinese hospitals throughout of the COVID pandemic. And you can see here an example of CT scans of the lungs. This is 14 days after they're doing inhalation. These are patients in the hospital. You can see on the left-hand side lots of cloudy lesions in the lungs, and on the right-hand side these lesions being absorbed there. And that's using this machine, which is Type 2 device approved in China now, so it's in hospitals. They've got it in hospitals in China. Unfortunately, it is a PEM machine, so it doesn't generate the electrically expanded water and the other ingredients we're talking about, Brown's gas, and machines that use an electrolyte are actually doing to provide that volume of gas. Here's another example. This is after 5 days. You can see really major improvement in the lungs. And we've seen this improvement on the ground with real life people that we're helping with it. So we've had very acute effects using hydroxy with COVID and long COVID cases. So these are acute effects, actually
Katie.
where there are shortness of breath, even asthma attacks, where hydroxy and Brown's gas has worked acutely. Wanted to share just one particular example. Although there are many, I could have shown this particular one, just play.
It's true, and I'm thinking, is it a coincidence? But
which I found on Facebook.
I thought I'd share it anyway, just in case it could help somebody else. So I've been ill now for just over 3 months, which I know is nothing compared to some people. And up until 3 or 4 days ago, I was unable to do simple things, chronic fatigue. I couldn't just wash up, couldn't go sort of more than an hour without lying down, felt nauseous all the time, just felt like I had a constant hangover. Literally was thinking, I don't know how I'm going to continue living like this. I had 60% lung capacity, which they think was a result of the pneumonia I had 3 months ago, but also they suspected I probably had long COVID and didn't really have a solution as to how to help me. So through a friend, I noticed a hydroxy machine, which is what I've got on now, as you can see. It's a massive thing. And I saw them using it on Facebook and just thought I'd inquire, and spoke to a guy called Richard, who was really non-salesy, sort of really knew his stuff scientifically. And I'm kind of really sceptical as to how, can this hydrogen therapy, which is essentially what this is, so this is me breathing in, I believe, I don't understand the details, I think it's 60% hydrogen, 40% oxygen, and I thought I'd just give it a go, not really expecting to see much difference. Anyway, I've been doing this for 4 days now, and I started with just 15-minute sessions 3 times a day, which is what you're supposed to do. I've worked up to 1 to 2 hour sessions a couple of times a day, and I have gone from being able to do nothing to feeling normal again. Today I went into town, did some shopping, went for some lunch, had a couple of cocktails, came back, done some yoga. Keep expecting to crash, but I haven't, and I just feel like it's totally changed everything. So I kind of was thinking I'll leave it for a bit longer to see if there's a catch to this and it doesn't sustain how I feel. But like I said, there'll be some people that might just want to look into it straight away because they're desperate, and I don't really know what I would have done without it, because I can't attribute my recovery in such a quick amount of time to anything else. I don't know what my lung capacity is now. Obviously, I've not sort of been back to get that measured in the space of 4 days, but I will be at some point. But I'm just so grateful and shocked to feel normal again, and I'm eating normally as well. So before, I'd gone off all kind of healthy food, just wanted carbs, and now I'm kind of feel like regulated, so I can eat stuff that I normally would eat. So yeah, if you have any questions and you want to just sort of speak to me informally, let me know. I'm happy to sort of chat to anybody. Also recommend.
Anyway, so that's just a good example of many similar others that have had quick turnarounds within the first two days normally of these types of symptoms. So it appears that there is, on the ground anyway, from our point of view, it seems to be like there's much better effect happening with Brown's gas hydrogen type machines than their PEM type of hydrogen machines. And this is predominantly down to, like what we're following on from the observation of ORP, there being a clue there that there is a stronger therapeutic potential for Brown's gas than there is for hydrogen gas. Having said that, look what hydrogen gas has done in China in clinical trials. Obviously, it's good. We'll talk about now the dosages. So I'd like to end with this and just give some bit of steer to everyone about protocol. So there are a number of questions that come from people about how often I should use the machine and what I should do and so on. Should I get a water bottle? Should I get a breathing machine? Well, first of all, we start from the beginning to say they're not the same thing. It's not an either or situation. You get a breathing machine to really use hydrogen and Brown's gas in the best way possible, but also you drink water, so you should also use drink very well purified hydrogen rich water. That's what we recommend, unless perhaps you are looking to do a deuterium depletion, deuterium being heavy hydrogen, being responsible for destructive biological processes. We can get deuterium tested in our breath, and healthy level is considered between 125 and 135 ppm. So if everyone over a certain age can actually look at doing a deuterium depletion, which I've done myself, and if you do that, you could put the deuterium depleted water in a hydrogen water bottle to make hydrogen rich deuterium depleted water. That's the protocol for doing a deuterium depletion. A deuterium depletion is a hydrogen rich deuterium depleted water exercise for however many months it takes, could be up to 6 months, but usually 3 or 4 months maybe of drinking that water to do a depletion. And there's a test available to anyone looking to actually find out their deuterium level before and after. So using the machine, it's really a lot better to think about what really happens in naturally when we eat food. The fermentation process, 20 to 30 minutes later, we're gassing off a lot of hydrogen, and our body is using this hydrogen. And this happens after we eat meals or drink sugary drinks. So or snack even. So if people who might eat breakfast, lunch and dinner are getting this big sort of liters of hydrogen generated after these episodes, as long as they've got the hydrogen producing gut bacteria in the gut. So the protocol for anyone obviously with a chronic disease or an ailment they're dealing with, or just wants to be healthier and do the best, use the gas to its full potential, is really to of course you're tied to a cannula to the machine. So when you're breathing, you can do it while you sleep or when you're snoozing in the morning. So there's always an opportunity to use it before bed, while you're sleeping, as well as in the morning when you wake up and snooze, if it's not or still on. So you can use it for a long time, as long as you do proper maintenance, keep the machine well topped up, and do good maintenance, use it frequently. So it's actually better for someone who is doing 3 hours a day to do 3 1-hour sessions than it would be to do 1 3-hour session, is the point. So the protocol, there's plenty of evidence in studies. I'm not going to go into them in detail now, but I'm just giving you the summary that using it more frequently is better. Drinking hydrogen rich water throughout the day is better, and using it when you've got the opportunity. Now, machines are portable. You can move them to your workplace, your office desk. You can move them by your bed. You can put them on a trolley and wheel them around. So think about practical ways that you can use it. You can wheel it into the living room and watch a movie. You've got a couple of hours there to actually use it. So it's all about having consistent approach. Keep at it. You're not necessarily going to see a miracle overnight. You might see that over 2 months or 3 months, but that means 2 or 3 months of using it every day. Make it part of your ritual. And I do that. I do my top up and everything, water change before bed. I turn it on, go to sleep with it on. I might be getting 2 or 3 hours before a cannula falls off, but then I'll wake up in the morning and turn the machine back on and get maybe half an hour. And if I can during the day, get some time. But we've seen this evidence with patients with Parkinson's whose tremor symptoms come back after, say, 3 hours or so after stopping using the machine, after however many hours they were. So there's plenty of people with Parkinson's now using the hydroxy gas machine who are having a breathe up to half an hour, say maybe 3 or 4 times a day, and therefore that shows you that if they were generating the hydrogen naturally like we do after eating, we would actually maybe see those symptoms managed even better. So therefore, when it comes to protocol, remember that frequent use is better. Remember to go do all the safety stuff we talked about. Whichever machine you end up getting is fine. Hydrogen is good, so it doesn't matter. Everything is good. But make sure that machines have safety built into them. Those devices, those pressure switches, these boards, these things do actually need maintenance. So you need to be using a machine where there is a country-based maintenance team that are able to MOT and safety check your device every so often. Just like a car needs to be on the road, it needs to be safe. Any hydrogen generating machine will need pressure switches and stuff in it. These are parts that fail and need testing, and they might not have necessarily redundancy built into them. So it's really important that whichever machine you choose, make sure you're getting it from a source where they are doing proper safety, maintenance and testing. And that's really all I need to say in this presentation. So if there's any questions, please write some comments, and I will get round to answering them, and or it will help me address any other questions that you've got in the next video. But thank you very much for listening, and I hope it was useful. Thank you. Bye.